Welcome to clickmateprojects.com. Here we are going to discuss about ASIC and FPGA implementation of the Gaussian mixer model algorithm for real-time segmentation of high-definition video. Background subtraction is an early and essential processing component for many video application systems. Its goal is to separate out the foreground, or more accurately the region of interest, from the region of the video. Over the years, background models have evolved from a static single Gaussian representation into more complex models such as adaptive Gaussian mixers to handle real-world conditions. Several researchers have applied Gaussian mixers for background modeling in surveillance applications. However, the discussion often focused on overall system performance, and background segmentation was often applied in an Addons manner. Many methodologies for background segmentation have been reported almost one as every object tracking system. Typical systems rely on a training period to collect statistics of the true background representation by means and variance, or a period of bounds. Recently, automatically background segmentation based on more complex models have been proposed. We favor the Gaussian mixer model over the non-parametric kernel-based approach for its efficiency and analytic form. Some formulations of this process have been made, however, usually in a very constrained context. For example, a framework based on explicit modeling of the illustration of other illuminations and surrounding noise was proposed. The system is not adaptive to scene changes and requires a training period, leaving limited application context. A more general treatment of the problem was provided, who outlined various properties a background modeler should possess and process a three-level processing framework. However, no framework at the pixel level processing was offered. In this base paper, we present Gaussian mixer model for background segmentation to remove the drawbacks in previous methodologies of background subtractions. Here, the Gaussian mixer models or previously act as a segmentation algorithm is very famous in medical image segmentation algorithm. Now, this algorithm was proposed in our ASIC and FPGA implementations architecture to propose the Gaussian mixer model to segment our background images from our original video framework. From each and every Gaussian mixer model architectures, this will connect the Gaussian kernel features of each and every points of the pixel regions of our given video frame. From that given video frame, it extracts the Gaussian components, and finally it separates the each and every clusters which are found in the same structure, and this will separate foreground and background separation from the given video formats. Then finally we represent a square box as a background subtracted images. Now I am going to explain the flow diagram of our project. In the first stage of our flow, we give the input videos as a video format. Then from the video file, it just converts the each and every frames and file as an image format. From the image format, it just extracts the each and every pixels and frame as matrices. In the matrix arrangements, these pixels are considered as values. From the values, the backgrounds can be separated by extracting the Gaussian kernel features of each and every pixels which are related to that separated initial values. From that each and every iterations, it checks the iterative loops of each and every clusters, and then finally group these clusters in a single framework. From the extracted clusters, this was labeled as a background and foreground. The backgrounds are labeled as zeros and the foregrounds pixels are labeled as 1. The final result of the segmentation result was began as an binary images. Then these images was get back to as an blobs. These blobs are considered as a clusters of formations which are pixels relative to the backgrounds and foreground separation. From the background and foreground separated images, we provide an rectangular box representation to denote the foreground separated image pixels, and finally we extract the segmented result as a binary image. Then from the binary image we finally displays the rectangular box to structureize the which of the pixels are grouped to form as a block, and finally this was separated and segmented. Now I am going to explain the running procedure of our project. Now just run mainfunc.yum file. Right click it and click run file. Here in the first stage we use the input video. Here I use the original doc.aba file as an input video and click open. This will display the initial iterations of each and every frames. Here this is the first load input frame. Then after that it will open the Xilinx. In the Xilinx code we simulate the operations of our internal architectures which are proposed in the FPGA design. This will open the code file which are proposed in the Xilinx tool. Here we can simulate according to the Gaussian mixer model algorithm. In this case we propose all the algorithm details of Gaussian mixer model, and the other components actions are proposed in this Xilinx simulator. Here we use the MATLAB as a reading of frames and writing it and send as a file to Xilinx simulator. Now just select simulation and select the main function and simulate behavioral model. So after that running the procedure, we displays the timing diagrams of our proposed structure. Finally this was running finished by the Xilinx simulator. So our FPGA output will be loaded in the notepad file format. Then these files are read by using MATLAB simulator. So here this can be closed, and after that this was waiting for our user command. Now just enter any key to display the background and foreground, and finally the tracked result. Now just click the enter. So the figure 2 represents the background images. This will be displayed as a binary image file format. Then the binary files was represented as a rectangular, which denotes the movement of each and every structures of the person, which are proposed by previous and present differences. This is the background separated database. This can be run for each and every frames. So after that we just simulate the Xilinx code. So for each and every frames the Xilinx will be open and we have to simulate it. After we simulate it, we just close the Xilinx and press any key to run next frame. The frames will be updated for each and every iterations. Then finally we represent the rectangular box as a tracked area, which denotes the moving area of the image file. Thank you.